This is the third video on factoring trinomials, and we're going to take the difficulty level up just a little bit today. We're going to factor trinomials of this form where the leading coefficient a is present and not equal to 1. Now, I would categorize these problems into sort of two families. On the one hand, we'll have a trinomial like this. The leading coefficient here, 8, actually divides into all the other terms. When you come across that, you're going to want to divide all of these by 8 and reverse distribute the 8 out. That would look like this. 8 divided by 8 is 1, so you can write 1x squared here, or just x squared. 8 divided by 8 again is 1, so you can write 1x or just x. 48 divided by 8 is 6, so we end with minus 6. That would be step 1. Step 2 is check to see if this is factorable. So for a minute, you can pretend that this 8 is not here, and just concentrate on x squared plus 1x minus 6. Now, in the other video, we saw what to do about this. We would write two binomials like this. Each binomial would start with x because x times x makes x squared. Then we're looking for ways to multiply to make negative 6. The 8 just brings down like this, okay? Ways to multiply to make 6 are 1 times 6 and 2 times 3. But to make negative 6, you'll need one side or the other to be negative. I'm going to put negatives on the little side just because I saw that the middle was positive, and it seems like negative 2 times 3 not only makes negative 6, but if I switch to addition and do something like this, they will add up to positive 1. And those are exactly the kind of numbers that you want to finish off these binomials. So this one is x minus 2, and the other one is x plus 3. And that problem is complete. Let's do another one. In problem 2, the leading coefficient 4 actually divides into 28 and 48. So again, you're going to want to divide all of these by 4 and pull the 4 out of the trinomial and think about, okay, well, what's left behind? Here, 4 divided by 4 is 1, so you have 1y squared. I'm just going to write y squared. 28 divided by 4 is 7, so I'll have 7y, and 48 divided by 4 is 12. Now, pretend the 4 is not here for a minute. Just think, how would you go about factoring y squared plus 7y plus 12? Well, you don't have any negatives here to confuse you, so you just need to come up with all the ways there are to multiply to make 12. So we'll bring down the 4, we'll write a y here and a y here, and then we'll make a little list, ways to multiply to make 12. In the previous videos, I showed you how to come up with this list on your own with a calculator, just by dividing by 1 and 2 and 3 and so forth. And then if the result comes out to a whole number, then you'll have some numbers you can put in this list. I like 3 and 4 here because not only does 3 times 4 make 12, but 3 plus 4 is 7. That matches what's here. So this is 4 times y plus 3 times y plus 4, and that problem is complete. In this third problem, the 7, the leading coefficient 7, actually divides into 63 and 140, similar to the two previous problems. So I'll take the 7 out. I'll write the trinomial that remains after I divide all of these by 7. 7 divided by 7 is 1, 1x squared. 63 divided by 7 is 9, so you have minus 9x. 140 divided by 7 is 20. Okay, now I'm going to factor this trinomial as a product of two binomials that look like this, x and x. Some numbers that multiply to make 20 that also happen to add to make negative 9. Well, the usual way to multiply it to make 20, like 1 times 20 and 2 times 10 and all these, they're not going to help you get the negative 9 in the middle. So in the previous video, we discussed how for a problem like this, you need negatives everywhere. That's right. Just sprinkle these all over. And you'll notice that the last combination is the correct one because negative 4 times negative 5 is 20, positive 20, but negative 4 plus negative 5 is negative 9. The only way we can improve this answer is to remember to bring down this 7. And we can do one more of these, and then we'll get to the truly difficult problems. Okay, all these divide by 3. So if you take the 3 out, what will remain is a trinomial, that looks like 1x squared plus 1x minus 2. So I'm going to write x squared plus 1x minus 2, like that. Then I'm going to factor this trinomial into the product of two binomials, such as x times x. And right here, I think that what I need is a minus 1 times a positive 2. Let's check to make sure that would work. X times x is x squared. X times 2 is 2x. 1 times x here is negative 1x. And so that would help us match what's there because 2x minus 1x makes 1x. And then finally, negative 1 times 2 makes negative 2. Don't forget to bring down that 3. And that trinomial is factored. Now, we're going to look at a collection of problems that's just a little more difficult. So I remember doing these in high school, and I really hated them. I did, because the method we were taught was pretty much a trial and error method. And if you're really good with numbers, it works. It's probably faster than what I'm going to show you. But this method is foolproof, and I found this on a website. I don't know if it's still a website anymore. It's called purplemath.com. This is not an advertisement for them. I'm just telling you, this is where I learned this. After, high school, college, graduate school, I'd never seen this before. So anyway, let's take a look. Notice that these three numbers do not divide by 3. 6 does, but 11 doesn't. You want to make sure that there's no common factor that you could pull out. So for example, sometimes they will all divide by 2, and you should do that before you start this process. But this time, these three numbers are what is known as a relatively prime. In other words, they don't have any common divisor other than a 1 or a negative 1. So since there is a number here that's not equal to 1, and I can't divide all of these by 3, I'm going to go for this method, the box method. You're going to need to see this 2 or 3 or 4 times. But you just draw a box that's sectioned into 4 boxes like this, and you grab the first and last terms and write them upper left and lower right. There's probably other arrangements that would work. Don't do anything with 11 right now. We'll come back to that in a minute. Now, take the 3x squared and the 6 and multiply them together. I'm just going to leave the x squared off. 3 times 6 is 18. And then, with a calculator, if you need it, write down all the ways there are to multiply to make 18. So, 1 times 18, 2 times 9, 3 times 6, and that's the end of the list. What you want for this problem is the 2 and the 9, because they not only multiply to make 18, but they also add to make 11, the term in the middle. So put the 2 and the 9 in here, and it doesn't matter which one goes where. I'll put the 2 down here. I'll put the 9 up here. And if this is x squared, these are going to need x's, just x's on them. Okay, almost done. Now we have to find the greatest common factor in this row and write it here. These both divide by 2. They don't both have an x factor, so I won't bring an x out. These both divide by 3. They do both have at least one factor of x, so bring out an x. Now, 3 and 2 are relatively prime. You can't really divide those by anything except a 1. Put a 1 up here if you want, or just put an x. And the reason I gave an x up there is because I was able to get at least one factor of x from both of these boxes. Now, what's the greatest common factor in this column? These both divide by 3. We have just produced our binomial factors. And you can write them down in either order, but a factorization of this is this factor times, and then on either side of it, 3x plus 2. And you can put it on the left or on the right, but that's how this factors. Multiply it all out and check to see if it really works, but trust me, it does. All right, here's a similar problem. The numbers are kind of small. There is a negative in the middle. That's going to make this a little bit harder. But why I'm reaching for this box method, again, is because this 6 does not divide into the other two terms. And there is no common factor to pull out at all. You got to make sure you don't have a common factor. When you don't, you'll go ahead and make this box. You'll divide it up into 4 components like this. In the upper left, what do? We just grab this one. In the lower right, we put that one. Then we take the two numbers from these boxes, the 6 and the 1, and we multiply them together. That, of course, makes 6. And now we're going to write down all the ways there are to multiply to make 6. 1 times 6 and 2 times 3. Or, if you're trying to get negative 5 in the middle, but you want to get a positive 6 here, you could put negatives on all of these. And you're down to just 2 options here, and this is the correct one, because it not only multiplies to make 6, but it adds to make negative 5. So put the negative 2 and the negative 3 in here, and attach x's to them. Okay, one more rule. When you're finding the greatest common factor in this row, you're looking for the largest positive number that divides into both of these, and it's just 1. But if the closest box here is negative, you're going to want to pull that negative out to go with your greatest common factor. Now, these both divide by 3, and they both have x. At least one x, right? I'm going to stay with positive, though, because although there's a negative in this row, it's not in the closest box to this. So this is positive. These both divide by 2, and they both have x, and the closest box is positive, so I stay positive. These both divide just by 1. What kind of 1? Positive or negative? Well, the closest box is negative, so I put a minus on that. Those are the binomial factors. So this factors as 2x minus 1 times 3x minus 1. Or you can do it backwards and put 3x minus 1 first and 2x minus 1 second. Let's do at least a couple more of these before we conclude. This 2 doesn't divide into that 19. It does divide into 24, but you're not going to be able to dismiss this 2 just by dividing all these by 2. It won't work. You're going to need this box method. So let's write down a box with 4 subdivisions, and we'll put the 2x squared in the upper left. That came from here. We'll put the 24 down in the lower right. We'll multiply the 2 and the 24 together. And then we'll come up with all the ways we know to multiply to make 48. You want to have an organized, structured list. You want to start with 1 times 48. Get your calculator out. 2 times 24. Will 3 go into a 48? Well, we'll divide 48 by 3 in a calculator, and it says 16. So 3 times 16 is 48. 4 times 12 is 48. And 6 times 8 is 48, last but not least. Now, one of these was going to help you get the negative 19 in the middle. Yeah, so this is a case where if you're aiming for a positive 48 multiplying, but a negative 19 when adding, you'll need negatives on both sides of this list. So just go all the way down, negatives on both sides. And the combination that you want out of these 5 is this one. Yes, negative 3 times negative 16 is 48, but negative 3 plus negative 16 is negative 19, and that's the reason I selected these. They go either here or here. If somebody does this in the other order, they're still going to get the answer I get. Negative 3x here, negative 16x here. Okay. What's the biggest number that divides both 3 and 24? Why, that's 3. Greatest common factor. Closest box is negative. What's the biggest number that divides 2 and 16? That's 2. But don't forget, these both have x's. And the closest box is positive, so I'm staying positive there. The biggest number that divides both 2 and 3 is 1. So up here I put a 1. Or I'll just put the x, because both of these give up x's. You may have noticed that when we run this little algorithm, these two have x's and these two don't. Okay, the greatest number that divides 16 and 24 is 8. Let's go with a negative 8 because the closest box is negative. these are our binomial factors. So I would factor this as x minus 8. That's an equal sign there. X minus 8 times 2x minus 3. Or put the 2x minus 3 first. You have the luxury of pausing and rewinding, but if you want to see this one more time, I save the hardest problem for last. What makes this problem hard, you ask? Well, again, check to make sure that 20 won't divide all these. Also make sure that there's no number like, I don't know, 2 or 4 or 5 that divides all these, because if there is, you're going to want to take that factor out. So for example, if I had 20 here, 24 here, and 6 here, I'd divide all these by 2 before I start this box method. But anyway, we're ready to go. And we're going to put the numbers, 20x squared, or the expression I should say, upper left and the 6 in the lower right. If we need a calculator, we're going to multiply 20 times 6 to get 120. And then we're going to try to make a list of all the numbers that multiply to make 120. This is a long list. That's what makes this problem hard. But if you have a calculator, you can get, for example, 2 times 60. How? If you didn't already know, 2 times 60. Well, you just go 120 divided by 2, and the calculator will give you the 60. If you do 120 divided by 3, the calculator will tell you 40. So 3 times 40 is 120, and 4 times 30. 5 goes into 120, I think 24 times. 6 goes in there 20 times. 7 would not help you. But 8 times 15 works. Notice these are getting closer and closer to the same size. 9 will not go into 120, but 10 will. 10 will go 12 times. Now remember, the middle is negative. But we were multiplying to get a positive 120. The only other way I know other than this list would be to use all negatives, on both sides. And somewhere in this list, I trust, is a combination that not only multiplies to 120, but also adds to make negative 23. We just went right past it, didn't we? These add up to negative 23. So put these numbers up here in some order, attach x's to them, and then find 4 little greatest common factors, and this problem is done. What divides both of these? 2. The closest box is negative. You should put negative here. What divides both of these? Biggest number I know of is 5. Don't forget to bring out also an x. Okay, don't write 2 up here. 2 does divide 8 and 20, but so does 4. 4 is bigger. You want the greatest common factor. Pull up an x also while you're at it. And then I know 15 and 6 both divide by 3. And the closest box here to the 3 is negative, so we'll put negative here. That means we're done. So this factors as 4x minus 3 times 5x minus 2. And that is how I factor trinomials that have a number here not equal to 1, which also won't divide into the other 2 terms. Well, that's it for this video. Hope you enjoyed it. Maybe you learned something. My name is Eric. Have a good day.